Who here uses JavaScript daily? Pretty much a majority here. Who here uses TypeScript daily? A little bit less. I'm gonna give you a couple of decisions today while we are doing some demoing. So you get to decide if we want to do some TypeScript coding or JavaScript coding, but we'll get there when we'll get there. Is the slides looking all right to the back? Everything okay in the back? Yes. My voice is also heard to the back, I assume, since yes, of course. Yes, thank you. All right, let's get started. Juho said that was the boring part, so I kind of have a hard situation here because I try not to be boring because it's going to be an hour and 15 minutes, if that's what the timetable said, around an hour of me rambling on. But yeah, let's get started. Hi, my name is Matias Huhta. I'm here to talk about some code-first design with some popular JavaScript libraries and also just talking about writing APIs that spark joy. Kind of what we're going to be exploring today is three things. We're going to be talking about developer experience, how you can improve your developer experience, how you can make code that actually sparks joy. Then we are going to be talking about some web standards. If you have ever seen me talk before, you know I'm a huge advocate for web standards. I go to React conferences to talk about why you shouldn't be using React, so that kind of gives a glimpse into my life as an uphill struggler. Then we are going to be talking about complexity. Complexity being the one thing that nobody wants in their web project, and kind of how we can eliminate that complexity, how we can eliminate different things in our code base that kind of, well, don't spark joy, so to say. A little bit about me before we get started with the actually fun part. As I said, my name is Matias Huhta. I work here in Finland in Turku, actually, so a couple of hours on a train that way, I think. I work as a CTO at a small software company called Simpler. We do software consulting for private businesses, and currently we are undergoing a couple of larger projects, even if we are a small software house. I do a lot of open source work. I contribute to a lot of these tools that I'm going to be looking at today. And also, what happened? Yes, it's fixed. And also I build my own tools pretty much for, I didn't build this, so it doesn't work. Yeah, yeah, I build my own tools for a lot of my projects. I'm also a home brewer. I didn't bring any beers today, but hit me up if you want to taste some actually good beer. I organize a similar meetup in Turku area called Autarky Overflow. If you are ever in Turku or you have friends in Turku, make sure they check it out. And I'm also something I like to call myself as a developer tooling developer. So I build tools for other developers pretty much. That's pretty much the only open source stuff I want to do because I'm not in the product business all that much. I just want to make other people make better products. There's no socials. If you want to follow me, I'm not active on any social media, but if you want to follow me, drop a follow. I might tweet once in a year. So the plan of action today, as Juho said, that was the boring part. This is my boring part. We're going to be building something today. So we are pretty much going to be live coding the whole presentation after this slide. And we are going to be building a JavaScript frontend or a TypeScript frontend. I'm not judging. A Node.js backend. Node.js because we can use the same language. I prefer Java, but nobody wants to look at Java for an hour, so that's not going to be fun. Then we're going to be talking about how we can seamlessly integrate these two layers together and how we can make everything type safe and everything spark joy. So let's get coding. We tested earlier, but is the text visible to the back? Can you see the code? Yes. Perfect. Somebody at the window saw the code, so that's it. That means it's on the right size. So let's get started with our JavaScript application. Of course, the first thing you want to do is create a folder for your application. And unlike a lot of people, I like to start my projects with just a clean npm init. No npm create, no next create app, no whatever scaffolding or bundling you like to do. Just a honest to God, npm init, and if we take a look at the files we are getting out of it, we just get a package.json that has just the regular old stuff that everybody should be used to seeing. Then we're going to start coding like it's, well, I don't want to date myself, but 20-something, earlier than nowadays code. We're going to start with a HTML file. Yes, who doesn't like HTML files? We're going to take a small snippet over here and get started with our HTML file. And we already have a dependency here. We have a CSS style sheet that we need to import. Well, of course, we need to create a source folder and a CSS folder and a style.css file. And then we can maybe test it out that it works, so we can make something like the background red. And then we need something to actually show the page on our browser. We could just open the file through the file explorer, but we're live coding, so we want to be fast. So we're going to be installing our first tool today. The first tool we are going to be using is Vite. Who here has used Vite before? Pretty much everybody. It's pretty much the de facto build system, serving system, development server nowadays. It's built by good people. It's based on a previous project called ES Module Dev Server, which was built by a smaller team, and then the Vue creators kind of made Vite on top of that, and they did a good job. And then to run Vite, we just need to modify our start script. So we make a start script that just calls Vite. I know Vite makes a dev script, but there's a start script in npm, so why wouldn't we use it? We just start the project and we can navigate to localhost, whatever port that is, and see that we get a blank page. And if we go to our index.html, we can see that everything is working by doing a small hello world, and everything is working, so yay. First demo effect averted. Then, because we are a JavaScript meetup, pretty much we want to be importing some JavaScript into our code, so we start that by importing a index dot. Okay, the first decision you get to make, shall we make JavaScript or TypeScript? Can I get a show of hands for JavaScript? How about show of hands for TypeScript? Good, we're gonna write less code, I'm happy. I used to be a huge proponent for actually using just JavaScript. I have a lot of tools built that are just using JavaScript with JSDoc and like TSC stuff, whatever. So it's like type-safe JavaScript, so if you wanna hear more about that, come find me after the talk. But we are going to be building with TypeScript, so we can just start with TypeScript. So we make an index.ts file, and we test that it's working. Hello, everybody. And we open the development console. Let's put it at the bottom because size issues. Yes, we get a console log here, and we see that everything is working. Okay, we want to build a modern web application, so we kind of want to get away from the index.html as quick as possible, and we want to have declarative styles, we want to have declarative views, we want to have like everything function in our code instead of a markdown file that is the index.html. And at this point, you might be installing something like Vue or React or Solid or whatever with the current flavor of the month frontend framework. For my demoing, I'm going to be installing a library called Lit. Who here has ever heard or used Lit? A couple of people. It's a templating library by the folks at Google. It's used by YouTube. It's used by Firefox pretty much on all of their browser-facing or the user-facing browser features. And it's used by a lot of people around town. And we're going to be rendering with Lit because it's something that I feel is, well, enough for the job. We don't need a huge set of state management, and we don't need a huge set of tool chains and everything we want to build. We just want to have something showing up on the screen. And how would we do the same rendering we did in here, but in Lit? It's quite simple. We just call the, let's see, I need to import a tsconfig into my project so I get actual type hints. Let's see. Yes, it's loading, yes. So we just import a render function. What does the render function do? It takes a HTML template literal, and it takes a target where to render it. So if we just write here, for example, tra-la, lilo, tra-la-la, and then just put it into our document.body, and then we import the HTML2, we can see that it doesn't like TikTok memes from the 2025 because who does? So we have our same templating working, but in JavaScript land. Of course, we could just extract this into a variable. We could just take the whole thing, call it a view, say that view is exactly that. We add the same thing. Since we want to have clean code, we kind of don't want to write everything into a index.ts file. We want to make a file for our views. So we make a views folder. Who would have guessed the name? And we create a home view.ts because we are using TypeScript today. And we make for example, a function that returns a view. So it's a function that returns a function because we have to go deeper. And then we just take the contents of this and put it here. And then we can, all we have to do now is just import the home view, maybe even put it into a variable, and then call that. Oof. We have the same thing. We have it rendering in the DOM, and we have everything. Let's see if we can actually get the elements pane to see. We have everything here like it was rendered by the HTML, but it's rendered by JavaScript over here. So I don't miss any steps. I kind of have a checklist here, so I'm just going to check it out. The next decision of today, are we going to use raw CSS or Tailwind? Who here wants to see just raw CSS? Okay, scary. Who here wants to see Tailwind? Okay, it's a tie. I'm going to be making a tiebreaker here, and I'm going to be doing both. Because that's how a good project is built. No, that's the first mistake. If we want to be using Tailwind, we kind of just delete everything in our actual styles files because we want to keep our code base clean. And as I noticed, we didn't import the styles correctly because our background wasn't red, and it's still not red because it's not the HTML, it's supposed to be the body. Okay, perfect. But because we kind of want to see how complex systems are built, we're going to be using Tailwind today because it was kind of a tie and it brings more complexity, but we can kind of look at how we can manage that complexity nowadays. So to install Tailwind into our project, it's nowadays like easier than ever. Who here is still stuck on Tailwind 3 point something? And who has upgraded to Tailwind 4? The people who are stuck on 3 point something, please upgrade to Tailwind 4. It's so much better. It's like it's what made me actually like accept it to this presentation because it's, well, not horrible. And we just install Tailwind and Tailwind CSS./vite, which is just a compatibility layer on it. We're kind of at our quota on our packages because our packages, I have this rule like if I cannot fit my packages into one screen full of PageWeaver, I have too many packages at that point. So like half of these are dev mode packages, but whatever, it's still a lot of packages to be installing into your simple web project. So yeah, let's see if our styles work. Of course, they don't work out of the box. So if we use something like DextXL, it doesn't work. So what do we need to do? Well, some people might just go to ChatGPT, Claude, something at this point. Please don't. Check the documentations. The documentations is gonna teach so much more to you than any chatbot because every AI example I tried to get out of this kind of was giving me Tailwind 3 point something and not Tailwind 4.0 because they haven't kind of picked it up yet. Plus, for Tailwind, the docs are amazing, so you should read them. It's not like you're going to take more than an hour to read through the whole docs, and you're not going to read through the whole docs. But here we can see the first step was to install the tooling. the next step is to add the plugin to our Vite config. So we just go here, we make our Vite config file, and we just paste it on. Don't copy paste code from the internet unless it's the docs. That's the only exception I allow. And then we just look at the Tailwind CSS here, and we import it into our styles CSS. And no, we don't run npm run dev. We run npm start because npm start is a built-in function. We get into more complexity. Tailwind 4 requires you to have a module system instead of having a whatever the default of npm is. And what you can do there is just say, yeah, sure, bro, it's a module, and Vite is happy. Now, if we take a look at our project, we can see our Tailwind styles getting loaded. We can, I hope that's not okay, it stopped, good. And we're gonna check out our home view, and now we can even see that our editor is picking it up, because if we write text color, well, it's not picking up, but whatever. Okay, so we have styles loading, and we have views rendering in our JavaScript world. And we are still on quota. We don't have a... Okay, Tailwind is kind of messy with the libraries, but we still are kind of on quota on the libraries. So as I said before, we kind of want to keep complexity at a minimum. So add it only when needed. Well, you folks wanted Tailwind, so we kind of needed it at this point. But again, we are completely in control. We know what we are importing into our project. We know what we don't import into our project. We completely know what's happening in there, except for when the screens are not working. Next, if we want to make something actually reactive, we kind of want to build with components, because components are kind of what builds the web experience. Well, we haven't really installed a component system like a Vue or Vue or React or Solid or anything. But luckily for us, I installed Lit instead of just Lit HTML, and Lit actually provides us with a component system. Lit being a, I think it's sub 4 or sub 7 kilobyte library, kind of packs a punch. It really gives a lot of power for the developer without actually bringing too much complexity into a system. And since it's my presentation, every presentation I do live coding in has to include Pokemon. So in this presentation also, we are going to be building a Pokemon viewer. Yay. I was going to ask some question, but I don't want to date myself anymore. So we're going to be building a Pokemon viewer element, and it starts with a class that extends lit element. Ooh, classes, I hear some people be here like, why isn't it a function? Because classes are good. Classes work, classes do the thing they're supposed to do. Components should be classes in a lot of situations. And to get it to render something, we call the render function. It's as simple as that. And let's see if it works. We can just say, here be Pokemon, and then since we are using Lit, instead of having like this proprietary way to render components, Lit uses something I kind of was basing on these slides. It uses technology based on standards. So who here has ever used custom elements? Good. More than one hand. It's always, I'm always happy to see more than one hand of people there. So what custom elements are, well, it's easier to show than explain. We just tag this as a custom element, and we tell it to, well, it's not having a, no, this, thank you. Let's import it from the right place. We say it's a custom element called PokeView, maybe viewer. And when we go back to our home view, we can just say PokeViewer and close it, because auto-closing HTML tags aren't standard, except for image and inputs. Here I go rambling again. Just stop me when I go rambling. And also, what I forgot to mention earlier is, like, if you have any questions during any part of the presentation, just raise your hand and I'll get back to you at that point. So we imported our PokeViewer component, and we are using it as a regular HTML tag, nothing special. No linking with another file, nothing like too special, no JavaScript pretty much. I could just throw this into our index.html if I wanted to, but we are doing modern JavaScript and modern frontend, so we do it here. And we can see that our component is getting rendered. And if we, as I was saying, what custom elements are elements that are actually designed to expand or extend the actual HTML5 standard. So we have our tags like h2s, p's, divs, spans, and everything. But have you ever dreamed of like making your own tags? Like they can do anything, like they can view Pokemon even. You can, with custom elements, you can create custom HTML tags. They work like a regular HTML tag, but they provide extra encapsulation inside of the class itself. What this means is, even though this space here is affected by Tailwind, if we don't want to, this space doesn't have to be affected by Tailwind. So we can create capsulation of styles and capsulation of JavaScript. So we can make kind of these vertical slices to our program. We don't have to consider like, is this class going to be modifying some behavior around the code base that we don't want to be modifying, because everything is encapsulated into their own little chunks. And here we just create our own little playground called the PokeViewer. And let's create something actually interactable inside of the PokeViewer. Who here still uses form elements? Can I get a raise of hands? Not too many. I'm sad. Form elements kind of became a dying breed when React started introducing these like on-input handlers. So every single input on your form is kind of attached to the state, whether you liked it or not, or whether if you needed it or not. Most of the time, you didn't need it in your state. It's just cluttering up your runtime. It's cluttering up everything. Let's make forms forms. They're HTML and they're browser data until you need it, and then you can just grab it and use it however you want to. Well, let's add some interactivity to our project. We can just create an input that's a type number with a name of like PokeID or whatever. And we can make a default value of it number 1. Who knows what is the Pokemon with the number 1? You can, yes, Bulbasaur, my boy. And we make a submit button so our actual code is submittable. And it requires a get a mon. Let's make it an action button. So now we have a form. If we press here, we see that our form is making a GET request. Of course, we are doing a modern web application. We don't want to be making GET requests and like kind of fully loading the whole page while we do anything on the page. We want to kind of capture that submit event and do whatever we want to do with it because we're in charge. With lit, attaching submit listeners or any event listeners is easy. You just say @submit. So if you have ever used view, it's the same. I think there was on submit at some point, but is so much cleaner. And we can make a submit listener onto our code base. And we can then, because we're in TypeScript land, we can say this is a submit event. So cool. And then we can do what we need to do. So we need to prevent the default action of the submit. So if we submit, we are no longer doing a GET request. We are just launching JavaScript and staying on the page as we want to. Next up, we need to get the data from the form. Since we are not attaching it into a state, we are not attaching it into anything, we need to get the form data somehow. Of course, we could be like PokeIDs, document that query selector, that value, and just break everything. Or we could, again, use standard APIs, use the standards. So we get the form element. It's always the target of the submit element event because, well, not always, but here it's the target because it's the place the listener is attached to. It's saying it's just an event target, but we can just do like a little bit of live coding magic and use the forbidden as keyword. And if we just console log it, we can see that our submit event knows where the form is. So if we do this, we know there's a form element. How do we get the data out of the form element? We could go form query selector. No. No query selectors today. There's a standard API for this. Also, there's a API called form data. What does the form data eat? It eats forms. So we just throw the form in there. Then, who here uses the JavaScript debugger on their front-end projects? A couple of hands. Good. It's the superior way to debug stuff. And I'm not fighting about that. And if we look at the debugger statement here, we can see that we have our form data object here. But if we just look at it in the debugger, we're kind of not getting anything of value out of it. I'll try to zoom in a bit so the folks at home can also see, or the folks in the back. But what's so fun about the debugger is that we can inject any code into the scope at this point. We can interact with our form data. We can say that we want the pokey ID from the form data. It's not pokey-id, it's pokey ID. And we can see that there is data on the form. Of course, form data is so 2008 or whatever people want to call form data. So we want JSON. We want the modern language of pretty much everything nowadays, for good or for worse. How do we get that? Well, let's put my live coding skills to a test and write a reducer live on stage. Let's see if this works. It's a form entry. Then we just want to return the accumulator. Then we need to make it an object. Then we want to do something with the entry. The entry is an object of a pair. It has a string and a form data entry value, so it has the input name and it has the value. So we just put the entry -0 here, and we say that the value is entry -1. And if everything went correctly, we can say that this is the form JSON. And if we not console log it, debugger, always use a debugger. If we do a debugging session here, we can see that we have our form data, but we have also a form ID, a form JSON that has the pokey ID, reducing a form data into a JSON object in one go. Yay! No time for applause. We have to go fast because there's so much more we have to write code on. So what do we need to do next? We need to send this to an API that can kind of fetch us a Pokemon. We could use a regular old API that's on the web, or we could write our own that kind of does some parsing on it because we want to actually have something viewable today. So we kind of bench this project for a while. We make another project. We make our, as we promised, we make a Node.js backend. So we created an API folder, and we are going to be using a library called Hono. Who here has used Hono in their career yet? A couple of hands. If you haven't checked out Hono, check it out. If you are using Express, or if you are using Fastify, if you're using pretty much any other Node.js library, that's a declarative way of describing APIs. Hono is like those, but like with all of the, I don't know if I'm supposed to curse here, but it's all of the crap put out of it. I was gonna say something way better. But yeah, it's all of the good parts, none of the bad parts. It's still new, it has errors galore, but it works. We create with the Hono latest because there's a couple of libraries, they change from time to time, so I'm not trusting that I remember everything outright. So we use the creating function here, even though I said I normally don't use scaffolding, but on backends, the scaffolding kind of saves you because it presets everything. So what did we get from our scaffolding? We get a NeoVim error, that's what we get. We get a couple of files. We get a source file, a source directory, index file, tsconfig file, which is nice. We get a readme that has instructions like, yeah, just run these commands, you dummy, like every project. We get a package.json. Package.json just has a couple of lines of code. No like multi-line dependencies, just a couple of dependencies. One to run the dev server or the server in general and want to actually like give us the hooks. Nothing too special here. And we have a dev script because I don't know why people keep doing this, but start is so much better of a keyword because it's built into NPM. So let's see if we have a functioning API because they broke something last week, so this scaffolding didn't work last week. But let's see if it works this week. We go to localhost 3000, we have hello Hono, and if we try to find hello Hono, we can find it in the index.ts, and we can test that it works. We can say hello future frontend, and we can refresh the page and we see that it's refreshing it. So we have live development on the backend also here. So we wanted to create a backend that gives us a way of fetching some Pokemon for our application. We make an endpoint called Pokemon, we give it the callback function, and we can just make a kind of a hello world here, see if it works, say like ID is 1, name is my boy Bulbasaur, and that's enough for now. And if we go to /Pokemon, we can see that it's returning JSON. So writing apps and writing APIs has never been this easy. And now we actually have to get the data somehow. So for this, we are going to be using PokeAPI, which is a API for Pokemon if it's not clear. And we're going to be fetching some data to get the Pokemon. So we're going to use just fetch. Back then you had to use Node fetch, but nowadays Node kind of packages fetch inside it, which is really nice. And we get the Pokemon by saying PokeAPI /Pokemon/ the ID of the Pokemon, and we can make this like PokeID or something, and then we need to of course say what PokeID points to. We can point it to 1. Then we get the response object. What do we have to do with a response object? We have to get the data out of it. How do we get the data? We await the response.json function. What's the data? It's any. Everybody's favorite type in TypeScript, any type. Nobody knows what it is. So let's just throw it here. Let's see what it is. We refresh the page and we get a whole lot of data about Pokemon. Who has ever seen this much data about a single Bulbasaur? Holy crap. We kind of are just interested in a couple of fields here. So we kind of want the ID, the name, and maybe even an image of our small little boy. That came out wrong. So we get the sprites. We go to data.sprites. We don't have any type hints here because like how would it know what the typing here is, because it's an API call. Nobody has type safety. This is called foreshadowing. We're gonna just get the front default sprite here. We're going to get the data.name here and the data.id here. And if we fix our syntax errors because we can't write clear code, we see that we are able to fetch some of the data from the API and we can get a picture of our magnificent boy. Okay, let's ditch this project for a while, go back to our app project. Now we have an API to call, an API to fetch us a Pokemon. So we do the same thing here that we did on the other side. We make a fetch call. This time we just make it to a HTTP localhost 3000 and Pokemon, and it's a async thing because we use awaits, so we need to say it's async. Then we get the data by just again await response.json. You might be asking why I'm not just directly calling the PokeAPI, because we need to learn something today, so that's why. We get the data. Again, what is the type of the data? It's any. It's anybody's guess, pretty much. We can console log. No, let's not console log it. Let's debug it. Again, use a debugger. It's so much better in many of the situations. We can make an API call, and everybody's favorite foe of making a good live demo, it's CORS. Cross-origin resource sharing is not okay, even though everything is in localhost. Well, as I said, Hono kind of has this batteries included mindset. Like Doesn't pack too much, but it packs the necessary things. So we can just say, yeah, use cores. I don't care about security. And we do it again. And we hit our debugging endpoint. If we look at our debugger, here we see that our data is ID is 1, image is the image, and the name is Bulbasaur. Perfect. Not too much complexity, just passing data from one end to another. Then we need to display it, so we can actually get a clear demo of what we are making next. To display it, again, we don't need a state management system. We have lit element. We have the 7 whole kilobytes of lit element. That's all we need. Since we're using TypeScript, it's actually just a couple of lines of code. We just say that there's a property that is the type of object, and we call the property Pokemon. And we make it a type any because nobody knows what it's actually typed as. And then we can just say that the this.Pokemon is the response that we get, which was the ID and the name and everything. Now, if we go to the rendering again, we can just render this Pokemon. Again, it doesn't know what's happening here. It's like, what is going on? What is in Pokemon? What is inside the Pokemon? Nobody knows. What is the Pokemon made of? Magic, I guess. We just get the name and we get the Pokemon ID because we described the API just a second ago, so we know it's typed as ID, name, and image. And we know it because we just took a look at it, but that's not good developer experience. Again, we're going to come back to this. We're going to look at how it actually should be. And we're going to get this Pokemon image, and we're going to close it like that. So now if we just render our page, check out our errors. We get errors because we're reading undefined, because again, it's an any type. Nobody knows what's happening. So we don't even know it should be conditionally rendered. We're just going to save time and do conditional rendering the bad way. So just writing everything inside whatever these operators are, nullish operators, falsy-ish operators. And if we make a request, we can see that we are actually now getting data from the backend. But we are not having a good time. Everything is any, everything is just breaking apart. Nothing is safe, nothing is sacred. Now we're going to get to the part where we actually make this into a good setup. So the first thing we have to do is design our API so that it can be documented. Well, it's code first design, as it was in the presentation slides. So code first design means that we are designing through our code base. To do that, we are going to use a package in the Hono setup called Hono OpenAPI. Who here has worked with almost all hands, but kind of hesitant on a couple of hands there? We're going to be installing a couple of libraries again. We know what we are installing. We are in control here. We are not just scaffolding something. Like, I'm not talking about not having any libraries in your project. I'm talking about like keeping the sense in your libraries, keeping tabs on what you are installing and what you're not. Here we just install a Hono OpenAPI integration that just creates OpenAPI endpoints, a validator for Zod. Who here uses Zod? Plenty of hands. Who here is excited for the new Zod? The same hands, good. A couple of wavy hands maybe. So we're going to be using Zod. Zod is a validation library, so we can validate our responses there. I'm trying to go fast because I see that there's a lot of time that went into the first part of the presentation. So if I will just look at the documentation here, again, read the documentation. Don't just ask ChatGPT or whatever what you should be doing. So we want to be documenting a query schema and a response schema. Well, we want people to be able to query this endpoint by giving it a Pokemon. I'm going to be making some space here so we actually see what's happening. We can make a Pokemon query schema, which is a Zod object. So we're going to say it's an JavaScript object that has the field, let's say let's say just Poke ID. And we're going to say it's an optional string because, well, it's actually a number, but let's just say it's a string to save some time here. Then we have our response schema. We'll get back to that. Then we need to describe our API endpoint. So we go into our endpoint, we make a middleware called describe route. Describe route takes a description, who would have guessed? Get a Pokemon by ID. Exciting. It's almost written like that. Responses, it returns a 200, okay, so everything went well. Who describes a 200 response? Nobody. We're gonna say the context of that, and we're gonna say it's application/JSON, and we're gonna say there's a schema, but we're not gonna go there yet. And then we're gonna just let the formatter do the formatting, and then we're gonna do the other validation. So we're gonna do a validator. Is this the correct validator? I kind of messed this up at one point, so I need to make sure it's so the validator here is for the query. So when we are asking for the API with some data, we need to validate the data because it's not safe to not validate the data. And we can validate the JSON payload, we can validate the form data, so form data isn't dead yet. We can validate the query parameters, the parameters in the path, the headers, the cookies, whatever pretty much. Here we're just gonna be validating the query, and we're gonna give it the validator Pokemon query schema. So it's gonna be validating it against this bad boy over here. So if we now try to call our API endpoints, we get a nice success here because it's just saying that it's optional string. But if we said it should be an optional number, and for example said that the Poke ID is ASD, we get errors. The whole API craps the bed if there's a bad kind of code. So it doesn't give you the actual result and it doesn't break. It just gives you the error like, yeah, Poke ID is supposed to be a number, you gave me a string. What if we gave it a number? Is it happy with that? No, because everything in your URL is a string. Luckily, we can just say it's supposed to be coerced. I have no idea what that word even means, but it's coercing it into a number. So it's kind of like, yeah, I can get a string, but if I can kind of turn it into a number, it's all good and dandy. And if we take a look at how it acts with the ASD, we can still see that it's not gonna be happy with everything. So it's only gonna be happy with numbers. Okay, let's get the data out of it then. Here we just had the Poke ID, and if we were to say context.request.query Poke ID, it's not gonna be safe. It's gonna be string or undefined. But we just said it's a number. How is it string or undefined here? Well, we can, now that we have the validator middleware here, we can say that we want to go to a request and say we want to get the valid data. And it knows that we have a validated query in here. It doesn't try to give us anything else. And then we need to just go in, get the valid data out of it. And now it knows there's a Poke ID. If we just put this into a variable, it knows what it's supposed to look like. We get type safety on our endpoints because it's validated it. It knows it's a number or an optional because we just described it as a number or an optional. And it's like, if I get over here, it knows it's something of this type. So our code will fail before it gets here on a bad input. And then since it's an option undefined, we can just say that the default value is 1. So now if we just make a query with the Poke ID, we can see that the API is already accepting different inputs onto our endpoint. So it's giving us whatever is Darmantian standard, whatever. Okay, we have described this here. We can go back to the documentation because the documentation is so good. We can just, again, don't do as I say, don't copy documentation. Well, copy paste from the internet, but only from the documentation. So what was the like joy in doing that whole shebang over here, like describing the routes and everything? Well, by saying that there should be an OpenAPI endpoint in some part of our application, we get documentation. this is code first design. So we didn't do any documentation on any documentation tools. We just wrote code, described all of the actions on the code, got type-safe code, and we got documentation. We know there's a path called /Pokemon. We know there's a get endpoint that gives these kind of responses. We know it takes a query parameter called PokeID. It should be a number. And it has a description that's written like a 5-year-old would write it. Now let's get into actually validating that we're not sending bad data to the front end. So we make another query schema. So we make, or not a query schema, we make a response schema. You can name it whatever you want. I just like to name it explicitly. And then we can just take a look. We have an ID, a name, and an image. We can say that it should have a string, well, who would have guessed a string, and a string, but we can also say it should be an URL. So we can say that if it's a string but it's not an URL, it's gonna fail. And then we're just gonna say that there's a schema here, and we're gonna say I'm gonna check the documentation again, because documentation. We're gonna say there's a resolver here, and we're gonna say it needs the Pokemon response schema. Yes. And now if we take a look at our documentation again, we can see that our documentation isn't working because of a demo effect maybe, or maybe I'm just a bad programmer, maybe. Let's see. Let's try to find the bug, because it's supposed to work like this. Well, this is exciting. Let's see. Let's circle back. We have responses 200, content, not context. I'm a dummy. Content. So now we are content on our decisions, and we can see that we have this application description here. So when we are getting a 200 request, like okay, we can see that this should be an object of this form. We can see that everything works there. And if you have ever used OpenAPI, you know that you can create like a OpenAPI documentation endpoint. So by just describing what our, almost ran something risky there. If we just install this isn't something I usually install, but I'm just gonna show it anyways. And if we install it and then we just make this endpoint into reality by doing this, copying the docs and wipe docking it out, not wipe coding, just wipe docking it out. And then we just say npm start. Like, yeah, this is good documentation, but wouldn't you rather see the docs in this form? You have all of your endpoints listed. You know it's a get endpoint. You can even make test requests on it. You can send them. And all of this because you did documentation in your code. We see this endpoint being that you get a Pokemon by ID exciting. So this is the description we gave it. It gives us the endpoint, it gives us the curl command, it gives us the form of like what it's supposed to look like kinda. And it gives us all of these tools to work on the code without actually like opening Jira or opening Confluence or opening a stoplight or whatever paid tools are out there nowadays. So what was the joy in this? Like if it's only on the back end. Our front end still is just fiddling with responses and fiddling with any types. That's where we get to the final stretch of this presentation, which is we go back to our front end now. We have the back end fully documented, and the front end doesn't know anything about anything. The last tool we're going to be looking at today is Hey API. Who here has used Hey API before? Pretty much nobody. Hey API is based on OpenAPI TS, which was a TypeScript library that kind of generated OpenAPI descriptors. And then there was some guy on Britain that kind of took over the project because it was abandoned and made it approachable. And he's a really cool dude. I've done some collaborations with him before. And we're going to be installing the library here. So we're just going to be installing Hey API OpenAPI TS, which is the client, and a client fetch, which is just a small library on fetch, which is the native way to interact with the API. Then we're going to follow the documentation. So we're going to be going to our package.json. We're going to make a new script called OpenAPI and say it calls OpenAPI-ts. And if we run npm run OpenAPI, we get errors because we didn't configure it correctly. So if we just go to configuration, again, copy paste code from the internet because it's totally safe. And we can say this is openapi.config.ts, save it, just full send the copy paste, and say that the input is our, well, here we're just going to use the same endpoint that we were looking at before, so the OpenAPI endpoint. So this bad boy. And we're going to say the output goes to source.api, and we're going to be using the client fetch here. Okay, nothing happened yet, but as soon as we run the OpenAPI, we have code generation. We have 4 different files here. We have a client file. Let's full screen it. Client file that kind of just has a base URL set up and everything that the client needs to do to get communicating with the source. We have an index that is just a literal index. We have sdk.gen. It has a lot of just scary TypeScript. But if we go to the bottom, what is this? It's a function that is calling a URL/Pokemon, and it's called getPokemon. What could it do? And the last file is types. It has the same data. It has the descriptors that we gave on the backend. It has the response schema. It has the base URLs. It has everything. So what can we do with all of this? So instead of doing this fiddling around with JSON, stringifying and everything, we can just go here, call response, well, let's call it result so it doesn't clash. And we can say get Pokemon. And if we now take a look at the result, it's a result that has either it has the data and it has the type data and the error is undefined, or it doesn't have the data and the error is unknown, so the error is something not undefined, most likely. And it has a request and response because it's just good manners to return those. And if we took a look at the data, let's say this.Pokemon is result.data, we can see it's the form that we described on the backend. It's not this any shenanigans anymore. It's the form we actually described on the backend. And if we just pretty much, well, we can save the form data.json because I've grown attached to it. If we just do this and we look at our web application, let's run the web application. We can see our getAmon endpoint works. So instead of calling fetch and kind of like abstracting the layers between APIs and apps, we can, well, we are abstracting it here because we are literally just calling a JavaScript function, but under the surface, it's actually calling the API there. So we can kind of call code inside of our code, get typed responses back, and kind of like blur the lines between the front end and back end. So pretty much the thing that like Next.js is kind of doing, like has done for years, and a lot of different frameworks are doing nowadays. So they are trying to make it so that your front end kind of feels like a back end and your back end kind of feels like a front end, for better or for worse. So for the final stretch, we have the validation here. We have, let's see, the validation at work. So if we just say there's a query parameter called PokeID, and it's called formJSON.PokeID, maybe. Yes. And because we're kind of scruffed on time, I'm just going to be doing this. It's a string, trust me. It's a number, trust me. Yeah, sure. I'm talking about type safety and not making type safe code, but it's because of a time constraint here. And we are querying the API with the PokeID. If we get it a different PokeID, we get a different Pokemon. Yay, everything works. But this doesn't spark joy. It doesn't like, we're not going to be taking this type and putting it into our project like this. Nobody wants to be updating this. Nobody wants to be checking all of these places like, okay, our API endpoint is returning extra data. We have to type it everywhere because everything just breaks because nothing knows what's happening. Let's do what we do to our most beloved childs, we name it. We add a small import here on the backend side called zod OpenAPI-extend. And what does this extension do is when we have our zod schemas in here, we can say that there's a OpenAPI descriptor for the schema. And let's actually open the OpenAPI description so we can compare. We have the description for the schema, and we can say that this response should be named Pokemon. So see all of this mumbo jumbo here. Our magician is gone. We just have a reference to our schema here. And where's the reference? The complexity is here. We have a component schemas documentation. So any tool that needs to know kind of like what kind of responses it returns knows that there's a response shaped like this, and it should be called Pokemon. And now, if we go back to our front end, run the OpenAPI generation again. I'm just doing this manually so to emphasize. It's usually done by a build tool. And we go back to our generated types. We can see that we actually have a type for the object that we just created. So we have a name type, which means we don't have to be updating everything. We can just say this is a Pokemon. So if the API updates, we run the generation, the app updates, everything is in sync. I haven't written a single type into the front end, and yet I still have types in the front end, and the types are literally what the backend is returning because it's generated literally on the code, based on the code of the backend. So we get that. And now, as we said before, it's like really difficult here to know what's happening here because we don't know if it's whatever it is. It was an any type. But now our editor loves us because it knows like, yes, I know this. It's a Pokemon. I know that there's a name. I know that there's an image. And I can just check all the type and everything works. And now, sorry about that. For everybody listening through the mic. Now, if we go back to our application, we have, what? Oh, these are still possibly undefined. So we have our integration between our backend frontend. We have all of this documented. So for example, if we wanted to query this and we didn't know what the query parameters are, we have even the documentation on that. So all of the endpoints are documented like they were JavaScript functions because they quite literally are just JavaScript, well, TypeScript functions. And it gives you all of the completions you need, all of these tools you need, and everything that you need to do. For example, if we want to give a string here, it gives us errors because it's not supposed to give a string. It's giving a number. And we get type safety there, so we kind of get, well, not type safety, we get TypeScript type safety, so build time type safety. But if we still like disregarded the errors there and still just full send it back to the backend has our back. The backend has our back. Well, that's extra cringe. So it has us secured because it knows that it's not supposed to look like that, and it knows that it's supposed to be looking like something else, and it's all even returning us the issues that are happening there. So if we wanted to give validation nodes to our front end, we could just grab the response, say like, yeah, dude, the PokeID isn't supposed to be like a whatever you gave us. It's supposed to be a number. And if we even wanted to go further on documenting this, we could always describe it more. I'm kind of a old head on Pokemon, so in my opinion, the API shouldn't be giving anything else than it's greater than 0 and it's less than 385, so the third generation. So we can document that. We can go to our OpenAPI documentation. It gives the information here. If we try to query with a next-gen Pokemon, we get errors. If we wanted to say that there's something wrong, we can say like, this is only for people born in the 1990s and before. And if we want to do that, we can give custom error messages. Everything is in sync. Our backend knows what's happening. It's parsing the data from the front end. It kind of parses it through, validates it. It knows what's going to happen. It knows what's supposed to happen and what's not supposed to happen. It can rely on fully typed data, which is safe because it's run through the validator. Then it can give responses to the front end about those errors, and the front end then can act on those errors without having any pretty much custom code on the front end. It's just, you don't have to double all of your validations. You don't have to double all of your stuff from the front end or the back end. You can just document it with your code. You can just make it happy, make it spark joy. And let's see. And you can pretty much just write code, have a small subset of libraries in your code, know what's happening in there, and then you can just put it all together and have your front end and your back end kind of completely in sync. We're kind of running out on time, so I'm going to be going back to this now. So what did we do? We got to coding. We built a JavaScript frontend, we built a Node.js backend, we built seamless integration through the OpenAPI descriptors and the Hey API descriptors. We built type safety and we improved our developer experience because you don't have to be duplicating your types. You don't have to be working with any's or unknowns. You can work with actual types from the actual backend. We based it all on standards. We just took a couple of front-end libraries to make everything work on the browser. We built web components so that everything works based on standards. And we had a couple of tools to make everything spark joy. And when we were adding complexity, when we were forced to put complexity into our code, we did it with our own intention. So we didn't just run npm create whatever and install 2 million packages on your project. Every single package was kind of handpicked, installed explicitly by you, and like, well, for me, I've pretty much run through the actual code base, so I know what's happening there, but like, you know what's installed and what's not installed. And at this point, I would like to thank you. And if you want to find me on any socials, these are my socials. And if you want to talk more, I'll be here until whatever o'clock. So thank you very much.
Half an hour for questions or live coding. If you want
yes.
to do more coding,
if we have still time, I can kind of show a couple more cool things.
yeah, we have time, so please go.
Awesome, awesome. So first, if there's a burning question for somebody, yes.
Yeah, could you reiterate how do you generate this API and are there other changes picked up somehow automatically if you change the records?
Yes. The Hey API changes are generated by running the OpenAPI TS command. But if I wanted to, I could say give a command that's OpenAPI watch, which is just this. Actually, I can just configure it in the configuration. So here, I can just say watch equals true. So now when I go to, I can just, let's see, small moment. I can do this. And I can just run the OpenAPI again. It's run on watch mode now. So every time I make changes to my code on the backend, so let's see. For example, if I update the documentation here, it runs the, hold on, yes, it runs the generation again. So it's in watch mode. So what the watch mode does, it polls the OpenAPI endpoint every 2 seconds. And if there's a change in the schema, it runs the generation again and generates everything again. So there's a Vite plugin for this also. So you can just plug it into your Vite config, which makes it so when your front end is running, it's always polling the backend to get the up-to-date stuff. And everything changes accordingly. So if I go to the sdk.gen, we can see that the get Pokemon by ID is here. And if we just add exclamation marks, and we refresh this, yes, we can see that it updated without me running any commands itself. And what it's completely based on, it just pulls this API, it reads through the schema, it reads through the paths, documents a single function for every single path we have here, or every single method we have on the path, and then just like kind of runs through everything that it references.
Okay, another question. Does it have any versioning mechanism or any help for, like when we deploy asynchronously or new version of backend and frontend? Like how do you migrate?
Like, I mean, like, it doesn't have like version control per se because it's just a code stub generation tool. Yeah. So I mean, like, if the API version changes, you can run the generator, but since the generation endpoint is hard-coded here, if the API version changes, you won't be picking up those changes unless you explicitly change the version in your API, for example. And like there's no clear versioning because OpenAPI is kind of a living schema thing, so it's like you don't have complete versions of it.
How do you actually like migrate? So
You deploy a new backend with the new routes and everything, and then your front-end code, when you run the code generation, if it changed in a breaking way, it will get caught in the build phase because you're calling, for example, functions that don't exist. So, for example, if we wanted to name this by Pokemon by ID, and then we went to our, why is it breaking? We went to our PokeViewer, we can see an error here that it doesn't have a endpoint called Pokemon.
okay, but the question was, yeah, if you let's say you rename, it's not ID anymore, but identifier, so it will break right now. Like you deploy backend and frontend will already break. Like, is there some recommended, again, guideline mechanism? Like, how do they do this? Or it's just like, okay, ad hoc, do something.
I mean, like, at our project where we use this, we have a CI pipeline that kind of like runs the generation on the backend, or like the live backend before deploying, and then runs the build systems and checks everything works. And then if it like runs through the tests and runs through the code generation and the validation, it is safe to deploy because it's completely according to the schema. But if there was a schema change, the name changes, the parameters changed, it will be breaking the code if it references the old ones. So everything can be done on CI by just generating the new schema and then building your project. Okay. And yeah, the one thing I actually wanted to show here was, let's see, I changed that back. So we have the Zod schemas on the front end here, on the back end. So we have our index.ts over here. We have the Zod schemas here. Sometimes we kind of want to have these on the front end. For example, if we had a schema validation for our form data or our post requests JSON payload. Well, since the whole payload is documented in the component section and in the endpoints itself, we can just expand on our OpenAPI configuration. We can import a couple, let's see, default plugins, yes. We can get the default plugins here, but we can also just say, generate some Zod while you're at it. And when we then go back to this, small moment, is everything running? I don't know why there's so many. So npm start here, and then we generate the schema here, and it's on watch mode. So if we now go to our API folder, we have a new file here. We have Zod, and we have the schemas for the responses that we sent from the backend, and they are transported to the front end. They don't get everything, so if I don't explicitly say that the query should be validated in a certain way, it doesn't come here. But for example, if you are using a validator for your JSON payloads and you expose it through OpenAPI, it will be visible here, which means that in my front-end code, I could use zPokemon.parse or safe parse or whatever I want to be using to parse it. Of course, it requires me to have Zod installed, since Zod. Well, it works on Zod. But yeah, I can get all of those things flowing from the backend to the front end. And if you are not working in a, well, this kind of a bare bones environment, if you are using something like, for example, React with TanStack query or React query or whatever it's called nowadays, Hey API has scaffolding for you. So you can just say use React query, and then the output will output React query compatible things for you. So you can still use the OpenAPI schema, you can use the type validation, you can use all of the type narrowing that comes from the backend to the front end, but at the same time you can get all of the joy of having the OpenAPI schema on your front end and generating all of that on the fly without pretty much any stress. And it does everything. It does the mutations, it does everything. But like if you are working in just a come as you go environment, you might just want to have the regular Hey API set up here. Let's see if there's another things. If there's other questions, just raise your hand and I'll pick up.
How would it work without TypeScript? Because you gave a choice in the beginning, but Hey API is TypeScript.
Yes, it imports TypeScript types, but you are actually just had Vite, so Vite kind of just transposes JavaScript, TypeScript to JavaScript, and it doesn't do type checking. But like even if we had just a let's see, foo.js file, so just a regular old JS file, and if we allow JS, yes. Even if we do the Pokemon await get Pokemon, since JavaScript is JavaScript, it won't complain in a build step because there is no build step most likely. Like why would you be using JavaScript if you have a build step? At that point, like TypeScript should be a no-brainer. But you can get all of the type hints, you can get all of the editor support, you can get all of the developer experience enhancements, even if you're working in a JavaScript space. I'm not sure if there's a flag to turn these into JavaScript. I don't think there is, but pretty much every build system is able to transpile a couple of these files to JavaScript, or you can just run a TSC compiler through these and get the functions from the SDK, and pretty much everything else is just fluff for TypeScript compilers and TypeScript editors to run on. Is there else? No. If there's no more questions, I would like to thank all of you for your time, and if you have anything you want to talk about, well, privately, here's my socials, and I'll be here for at least half an hour. So thank you very much, everybody.